This video is all about the summary of Module 11. All switch port interfaces should be secured before the switch is deployed for production use. The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. By default, layer 2 switch ports are set to dynamic auto trunking on. The switch can be configured to learn about MAC addresses on a secure port in one of three ways: manually configure, dynamically learned, and dynamically learned sticky. Port security aging can be used to set the aging time for static and dynamic secure addresses on a port. Two types of aging are supported per port: absolute, and inactivity. If the MAC addresses of a device attached to the port differs from the list of secure addresses, then a port violation occurs. By default, the port enters the error disabled state. When a port is shut down and placed in the error disabled state, no traffic is sent or received on the port. To display port security, settings for the switch use the show port security command. To mitigate VLAN hopping attacks, Step 1. Disable DTP negotiations on non-tracking ports. Step 2. Disable unused ports. Step 3. Manually enable the trunk link on trunking port. Step 4. Disable DTP negotiations on trunking ports. Step 5. Set the native VLAN to a VLAN other than VLAN 1. The goal of a DHCP starvation attack is to create a denial of service or DOS for connecting clients. DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted ports. DHCP snooping determines whether DHCP messages are from administratively configured trusted and untrusted source. It then filters DHCP messages and the rate limits DHCP traffic from untrusted source. Use the following step to enable DHCP snooping. Step 1. Enable DHCP snooping. Step 2. On trusted ports, use the IP DHCP snooping trust interface configuration command. Step 3. Limit the number of DHCP discovery messages that can be received per second on untrusted ports. Step 4. Enable DHCP snooping by VLAN or by a range of VLANs. Dynamic ARP inspection or DAI requires DHCP snooping and helps prevent ARP attacks by: first, not relaying invalid or gratuitous ARP replies out to other ports in the same VLAN, intercepting all ARP requests and replies on untrusted ports, verifying each intercepted packet for a valid IP to MAC binding, dropping and logging ARP replies coming from invalid to prevent ARP poisoning, error disabling the interface if the configured DAI number of ARP packets is exceeded. To mitigate the changes of ARP spoofing and ARP poisoning, follow these DAI implementation guidelines. First, enable DHCP snooping globally. Second, Enable DHCP snooping on selected VLANs. Third, enable DAI on selected VLANs. Fourth, configure trusted interface for DHCP snooping and ARP inspection. As a general guideline, configure all access switch ports as untrusted and all uplinks ports that are connected to the other switches as trusted. DAI can also be configured to check for both destination or source MAC and IP address. Destination MAC. Destination MAC checks the destination address in the Ethernet header against the target MAC address in ARP in body. Source MAC checks the source MAC address in the Ethernet header against the send MAC address in the ARP body. IP address checks the ARP body for invalid and unexpected IP addresses including address 0.0.0.0, 255.255.255.255, and all IP multicast addresses. To mitigate snapping tree protocol or STP manipulation attacks, use portfast and bridge protocols data unit or BPDU guard. Portfast immediately brings an interface configured as an access or trunk port to the forwarding state from a blocking state by passing the listening and learning state. Apply to all end-user ports. Portfast should only be configured on port attached to end device. Portfast bypasses the STP listening and learning state to minimize the time that access port must wait for STP to converge. If portfast is enabled on a port connecting to another switch, there is a risk of creating a snapping tree loop. What is PBDU guard? This PBDU guard immediately disables a port that receives a PBDU like portfast. PBDU guard should only be configured on interfaces attached to end device. BPDU guard can be enabled on a port by using the snapping tree. BPDU guard enable interface configuration command. Alternatively, use the snapping tree portfast BPDU guard default global configuration command to globally enable BPDU guard on all portfast enabled ports. And that's all for the summary of Module 11.